Alright, here in this video we're going to check out 6.5 Applications of Linear Systems. So we've been learning all about systems of equations. Now we're going to take that knowledge and start to apply it to real-world situations. And what's special about systems of equations, it allows us to solve for two variables at the same time, both x and y. So we'll see kind of that concept going on here. There'll be one about darts, where we're solving for two different parts of the dartboard to figure out how many points each one is worth. It's pretty neat stuff. These get more interesting than your typical math word problems, because as you guys are starting to move up through the ability to solve more complicated math problems, you can do more and more cool applications. So I know that you guys are terrified of real-world problems because you feel like every single one's different and that they're impossible to figure out and that you can never seem to set them up right. So this set of notes is going to help us hopefully take some of that down, take some of that fear away. Here's some key components. Highlight important information. We're looking for numbers, right? If we're writing equations, we're going to be looking for numbers. So we're going to be highlighting important numbers to help us write two equations. So it's key to know we're looking for two equations. We'll define our variables, and that usually comes, in the problem, where the problem gives you the question mark. All right, if they're asking you a question, or they tell you, because they'll sometimes be like, hey, how much is this worth? How much is that worth? With question marks, or they'll tell you what you're looking for. Then we'll write the two equations. We'll use one of the methods of solving, which we've looked at graphing. We've looked at substitution. And we've looked at elimination. We probably won't use graphing a lot, because as you can see, there's no graphs on this graph paper. Now, here's something else I want to talk about. There's really only two types of scenarios for the majority of real-world problems for systems of equations that you're going to look at. If you have part whole, that's ax plus by is equal to c. A standard form situation there. Another type is if you have a starting point and then you have a change. That's our y equals mx plus b. Where this is the start and that's the change. So let's check this first one out. The school that Stephen goes to is selling tickets to a choral performance. On the first day of ticket sales, they sold 3 senior citizen tickets. Notice how I'm highlighting the important information. And 1 child ticket for $38. That's a part whole. We did some of that, and then it totaled to that. Second day, $52 for 3 senior citizen and 2 child tickets. It says find the price of senior citizen ticket and the price of a child ticket. That's telling us what our variables are. So let's have S equal price of senior ticket and C equal price of child ticket. So as you can see, nothing difficult has happened at all. They told us what we're looking for. It's the price of senior ticket and the price of child ticket. And then if we just substitute those variables in, it's that they bought 3, I'm here in blue, 3 senior citizen tickets and 1 child ticket. Part whole. Now for the green, 3 senior citizen tickets, 2 child tickets, and they said that was $52. So there are the systems of equations for that. Now in this video, I'm not going to focus on solving them because I just want to get you guys practice on setting them up. You guys can solve that with either substitution or elimination probably pretty easily and figure out the price of senior citizen tickets and child tickets. And this is what systems of equations does. if you have two equations that both contain the same two pieces of information, you're going to be able to set them up like this and solve. Two, suppose the fictional Sanex Ski and Snowboarding Club publishes a newsletter. Expenses are 90 cents for printing and mailing each copy, plus $600 for total research and writing. So here I've got a change, 90 cents per one I produce, plus a start, because the $600 happens one time. That's a starting value, and then a change. And then this one says the price of the newsletter is $1.50 per copy. How many copies of the newsletter must the club sell to break even? So basically what we're doing here is C is going to equal number of copies, because they're telling us to find the number of copies. Now, Y in this case is kind of just like a substitute. It's like a placeholder. So Y is kind of doing two things. Y is representing cost slash profit. All right, it's kind of doing both, and we're going to set them equal to figure out when they break even. So for this, the blue, it says, hey, it's 90 cents per copy plus a $600 setup fee. Then the other equation, it says, hey, you're making $1.50 per every copy, but there is no B value, there's no starting value on that, because if you're trying to make profit, you sell 0 copies, you haven't made any profit. So if I wanted to figure out how many copies I would need to sell to break even on this, we would use substitution and set these two Y values equal, and then solve. So this is a good one here too. Mark and Stephanie are playing darts according to the World Darts Federation rules. Each toss earns points depending on where the darts land. Each ring and sector is worth a different number of points. Mark and Stephanie both toss 3 darts in the first round. It happens that their darts only land in 2 areas of the board. That's important. If they did more than 2, we wouldn't be able to solve with our current systems of equations skills. So Stephanie earns 60 points total, with 2 darts landing in the first area and 1 dart landing in the second area, for a total of 60 points. You should be thinking now, hey, that's part whole. 1 of Mark darts landed in the first area and 2 in the second. He scored 75 points. So it says, write a system of equations, use X for the first area and Y for the second. They already helped us get that set up. So for Stephanie, in blue, 2 darts in the first area, plus 1 dart in the second area, and she scored 60 points. Here in green, 1 dart in the first area, and 2 darts in the second area. So that's system of equations solving this situation. Both equations both talked about the same 2 areas of the board, so we're going to be able to figure out exactly how many points both, so not just finding out one section, but both of those sections, if we solve this using either elimination or substitution. But notice what we've got. Part whole. Part whole. That's going to happen a lot, and so will y goes to mx plus b, but those are really the 2 types you'll see. 4 we'll do together. That one is that's off the math team. That one's a little trickier. Let's do Kelly and Chris. Selling wrapping paper for a school fundraiser. Customers can buy a box of the plain print or a box of the holiday print. So we have 2 things we're looking at. So Kelly sold 10 boxes of plain print, 12 boxes of holiday print, for a total of 380. You can probably already see this is part whole. Chris sold 6 boxes and 8 boxes for a total of 244. What's the cost of 1 box of plain print? So we could do P equals cost of plain print H equals cost of holiday print. Alright, so then we just set them up. Kelly sold 10 boxes of plain and 12 boxes of holiday for $380. Chris sold 6 boxes of plain plus 8 holidays for $244. Part whole, everybody. You can see it. Almost all these problems are the same. This one was wrapping paper. This one was darts. This one was selling tickets to something. But they're all almost the exact same problem. So that's one thing I want you all to understand about word problems, especially in the Algebra 1 arena, is they're not really that special. A lot of them are incredibly similar. So once you kind of get this pattern down, you'll realize that, hey, I can write real-world equations because most of the time they're going to be part whole. Or y equals mx plus b. Let's do another one. Number 7, that'll be another y equals mx plus b here for us. So it says, suppose you invest $10,410 in equipment to manufacture a new board game. Each game costs $2.65 to manufacture. So here's a starting value, because we got to buy that to, I guess, buy the factory or the molds that we're going to craft our pieces from. And then it also costs that much to make each game. And then it sells for 20. So y equals mx plus b is a lot of time about breaking even. Setting up your cost equal to your profit to find, where you're going to break even. And we can talk more about this when I'm back in person, but so let's just have G equal number of games. Okay, so for blue, each game costs $2.65 to make. So every game that I produce, for the materials, the cardboard, the plastic, costs $2.65. Plus, I had to invest this much money in the equipment in the first place, the machines to make the pieces. And then each game that I sell, selling for $20. So as you can see, you're selling it for way more than it costs to make, $2.65 compared to $20. But you're going to have to sell a bunch of games to offset the cost that it costs a lot of money in the first place to get it set up. And this is typical business practice. If you're doing a bake sale and you're selling cookies, you got to buy the dough and the chocolate chips, the butter, all that stuff up front. And then you sell the cookies for more money than it costs to make them, and you eventually, break even and then start to make some money. So all this stuff's coming back to systems of equations.